All right, so in this lab what we're going to do is we're going to look at solutions and mixtures. Specifically, as first part of the experiment, we're going to look at a saturated potassium chloride solution. So you can see here this is saturated because the way we can tell is at the bottom. You may not be able to see very well on shot here, but there's actually some solid floating around in the bottom, so we know this is saturated. So this solution still has a little bit left at the bottom that won't dissolve in, and this has been now trying to dissolve for about 24 hours, so we know this is saturated. And what we're going to do is we're going to take this saturated solution and we're going to figure out how much potassium chloride there is in a certain volume of this material. All right, so we're going to go back to the scales now. We're going to start the experiment over there. All right, so the first thing we're going to do is we're actually going to measure the mass of our watch glass here. So the first thing we're going to do, the scales are already on. I've already gone through their initialization sequence. We're just going to zero it out of habit. We're going to open it up. Since we still sometimes get a little wavering on that last digit, we're just going to zero it one more time like the habit I've taught. And then what we're going to do is we're going to weigh our empty watch glass. So for now you can take your measure. We'll give that last digit a second just to kind of balance out. The balance is up, so you can take your reading. Then what we're going to do is we're going to take our saturated solution, and you can probably see a little better here some of the solid that's still at the bottom that I was just talking about. And we're going to add about 6 mils to this. So we're going to use these like disposable pipettes. They hold 3 mils up to this mark right here. You can just about see that on shot. So I'm going to do 2 of those, so that way we're adding a full 6 mils. All right, so that's 3 mils. And once we've done that, I want you to take the final reading. So now we've added the 6 mils of the saturated potassium chloride solution. So now you have your reading for that. And then we're going to take this back to the end of the bench where we're actually going to evaporate the water that's in this system. All right, so we're back at the end of the bench where we're going to actually do the heating for this. So I've just put the watch glass with the liquid that we just weighed out. This is right here on the bench. And now what we need to do is we need to set up a Bunsen burner. But what we're going to do now, rather than using the normal clamp stand for this, we're actually going to set up a ring stand using the gauze. So we've used this setup a couple of times already in different experiments. So this will be pretty straightforward. Just get the ring, put it on the ring stand here. And then of course we have our gauze, because ultimately we're going to set a beaker on this that's going to act like a water bath. So we need a half fill, maybe a little more than half fill with water, a 250 ml beaker. So we're going to put about 125 mils in there. Because what we want to do is we want to get this so it can boil, but we don't want it splashing up over the sides, because we're going to sit this watch glass on top so we can evaporate the water off. So then what we're going to do is we're going to set up our Bunsen burner here like we normally do. We close the hole at the bottom. We'll grab our lighter and we'll turn the gas on. So now we have our system, but that ring stand looks like it's a little low. So we're going to carefully raise it up just a little bit just to make sure it's at a good height for our Bunsen. And then we're going to start heating that. And then we're just going to very carefully place our watch glass on top. And then as everything heats, we should hopefully be able to drive off that liquid. So all we've done here is basically just set up a water bath that's going to heat up the water on the watch glass. So I'm going to just raise it up here so you can see a little better how this all comes together. So on the top is our watch glass just sitting on top of the beaker. This is the water bath that's getting heated by the flame, and ultimately the liquid that's sitting in that watch glass that we just weighed out is what's going to evaporate. And we'll come back when that starts evaporating. So as you can see, after about 5 minutes, the water's hitting a rolling boil. You can see underneath the watch glass that water's condensing because the watch glass is cold. As the watch glass heats up, that'll allow the water that's sitting inside the watch glass to evaporate. You can kind of see it on there. It's a little hard to see. So I'm going to just turn the heat down a little bit so we don't get too vigorous a boil here. But we're still going to keep it nice and hot so that that potassium chloride solution that's sitting in our evaporating dish can actually evaporate, at least the water can evaporate. And we'll come back after that gets to that point. Alright, so this has been boiling now for about another 6 minutes. And as you can see, if you look carefully on it, you can see around where the inner part of the watch glass is where the liquid, there's still a bit of liquid in the center of it, but notice on the outside how now you're starting to see this material forming because the water is evaporating, leaving this residue behind. So you can make a note of this, sort of like your observation. As you heat it, you can start seeing this forming. If you watch, even as we're filming here, you can see that inner ring beginning to shrink and more residue forming on the outside. We slowed the boil down a little bit in the beaker underneath, so the hot water bath that we effectively formed, because we wanted to make sure that we didn't run out of water. If you find that your water is getting really low in your water bath, you may need to pause the experiment and carefully add some more water and then let reboil as you are driving off the last part of this water. So we're going to let this finish up driving off the last part of water, and then we are going to carry on this experiment. So as you can see now, it looks like all the liquid in the watch glass has evaporated. So what we're going to do is we're going to take this apart. We're going to take the watch glass off the top, and then we're going to break this down, and we're going to try drying. As you can see underneath the watch glass over here on the left hand side, if you look underneath, you can see some condensation underneath it, and we want to try and get rid of that. So we're going to take this apart and we're going to put this on some paper so we can dry the bottom, and then we're just going to gently dry it with a direct flame. Alright, so to take this down, what we're first of all going to do is we're going to turn our flame so it's not a full flame. We're just going to move that out of the way so we don't burn ourselves. And then what we're going to do is we're going to take the watch glass off the top. We're going to put a piece of towel down on the bench here. You can kind of see that in shot. The reason we're doing that is because we want to dry the bottom of this from the condensation that's underneath it right now. So we're going to try and lift this up carefully. We're trying not to let any liquid get into the dish, and we're just going to dry the bottom on this paper towel. Because obviously it's very damp after sitting on that water bath. Then we're going to remove the beaker because we don't need that anymore. Notice again that I'm using one hand to operate these tongs. I'm just going to carefully move that onto the bench out of the way. Once we've got this somewhat dry, we're going to place it back on there. And then we're going to directly heat it, but we're going to heat this much more gently than we did before. So we're going to put this on a little bit of a flame because these watch glasses are a lot weaker. So we don't want to directly heat it too much. We just want to heat this gently enough to drive off the last little bits of liquid that may be sitting on the top of that. So you just have to be careful that we don't crack this watch glass and make it too hot. And once we've done that, then we're going to, you can see there's a little bit of bubbling on top. So as you can see, there's still obviously a little bit of liquid in there. You can see the bubbling on the top as it's being heated. So we're trying not to let this spatter, which is why I'm doing it very gently. So I'm just trying to keep it hot so that liquid evaporates out fast, but try not to spatter it because we don't want to lose any of the solid. If it spits off the side of the watch glass, we need to have, we want good data here if we can. So we're just gently heating that, giving it a chance to actually respond and let the water evaporate out. So notice how I'm not constantly heating it, I'm just gently heating it a little bit now and then, just to keep it hot so it continues to evaporate, but so it doesn't spatter too much. You can see it spattering a little bit, so you don't really want to do it too much more than that. So again, we're using kind of like a handheld heat method here, so we just have to be careful. Just watch what we're doing with that flame. So I'm just going to let that sit for a while because it looks like it's pretty hot. So looks like it's getting pretty close. This is why when we first drive off the water, we do it all on the water bath. We don't do direct heating because we try to prevent spitting or spattering of that solution so that we keep as much of the potassium chloride on the watch glass as possible. Still looks like it might be a little wet underneath, so we're just going to give it just a little more. And then what we're going to do is we're actually going to we're going to weigh this, we're going to see what kind of mass we get, then we're going to heat it a bit more, and we're going to keep doing that until we don't see a significant drop in the mass, which means no more water is being driven off. So this looks like it might be fairly dry, so we're going to move this over to the top pan balance so that we can see what the mass of the system is before we heat it a little bit more. So we're going to zero our balance. And then we're going to bring our watch glass over carefully. All right, so there's our first reading after direct heat. Take that number. And then we're going to heat it just a little bit more and see if we get any more heat driven off. Sorry, any more water driven off, I should say. So we're going to put it like on a moderate heat flame again. And we're going to try heating that. It still looks like it might be a little damp around the outside. See that ring that's just a little darker around the outside there? There's probably a little bit of water in there still, so that's why when you see it starting to like pop and create holes, it's doing it in that area right there. We're doing this slowly. We're still getting a little spitting. It's hard to avoid some of that, unfortunately. So we're going to weigh this one more time now. It's looking pretty dry now. And we should zero, of course, and then we'll take our reading after the second time. All right, so very minor drop, so we can take that. All right, so in this section what we're going to look at is we're going to look at the miscibility, or the mixing or dissolution of two different liquids. We're going to mix two liquids that are very different kinds of liquids, so you can see what happens when they're not very soluble in each other. So the first thing we're going to do is we're just going to add about 5 mils of water to a test tube. So remember, we did this way back. We measured out what 5 mils in a test tube would look like. It was about that. So we're estimating that to be about 5 milliliters of water. And then what we're going to do is we're going to add a couple of milliliters of an organic system called cyclohexane. So in case you need to see the name. So we're going to take some cyclohexane. We're going to add about 2 mils of cyclohexane to our system. So that way, you know, the layer of cyclohexane is very much less than it is for the water. And we're just going to carefully add that to our system. Notice when we add it, I'm just adding it down the sides. And so what you can see now from this is you can see there are two distinct layers, and one of those layers is water and the other one is cyclohexane, remembering one of them we have more than the other. So you should now be able to say which of these is more dense. Generally things that are more dense will sink. So you should now be able to determine whether or not water or cyclohexane is actually more dense. So now we've got our system made where we have the water and we have the cyclohexane mixed together. We're just going to give it just a little shake from side to side. And we're going to see if it mixes well or not. And you've probably seen something like this before. If you make vinaigrette dressing, you see the oil and the vinegar, or the oil and the water phase, as it were. They don't really mix well, and you can kind of see the same thing here. There's a few little bubbles at the interface between the two layers, but really, there's not much there. Now what we're going to do is we're going to add this system. It's basically an iodine water mixture. And so this is the kind of thing you use for cleaning out wounds and things like that. So I'm just going to take about a ml or so of this. I'm just going to carefully add it down the side of the test tube. And when you look at that, you'll see that for the most part, when I add that system in, it sinks into the lower of the two layers. So that's your observation that when we first add the iodine water system, it all goes into one layer. However, if I just gently shake this, so the layers kind of mix up a little bit. Now if you look a little closer, you'll notice that the upper layer now is a little bit pinky purple in color, and that's from the iodine solution. Not all of it now stays in the other layer. So with a little shake, we start to see some of the material go from one layer to the other. So this gives you a sense of how different things mix. So initially our two layers didn't mix, and they still don't. And then when we added a third component to this system, we found that initially it went into the lower phase, and then some of it moved into the upper phase as we shook it a little bit. All right, so now what we're going to do is we're going to look at some different miscibilities of pairs of liquids. So the first thing we're going to do is we're going to take, again, some of the cyclohexane, and we are simply going to add about a half a pipette full of that into the bottom of the first test tube. And again, it's always good to make sure you put the caps on bottles because you never know what might happen. Just accidentally knock things over with your arm. And then to that one, we're going to add a small amount of water. Now we've already seen this, so this should be pretty obvious what's going to happen here. When I add the water, I'm going to add a little bit more water than the cyclohexane so that we can see clearly what happens with that system, and you can obviously see whether you see one or two layers there. So that's just with the initial addition. Now if we were to shake this a little bit, we can see whether or not we think the system is miscible, and you can look at that after shaking it for a bit. It almost immediately reseparates, right? So you can now determine whether or not those two liquids mix, or what we call miscible. Now what we're going to do is I'm going to add some water into a test tube, and I'm also going to add some isopropanol or propyl alcohol into the same test tube. And as I add it, you should be able to see whether or not it initially mixes or not. So when you look at this system a little closer, it's a little different to the first test tube. You notice that even just on normal addition, you don't really see any layers there. It looks like a single phase. And of course, we'll do the final pair where we'll take the cyclohexane And then to that test tube, we're going to add the isopropanol as well. So cyclohexane first, and then we're going to add the isopropanol. I'll add a lot more of the isopropanol, so if there is 2 layers, we'll know which one is which. Now, if you look at this, we have 2 pretty distinct layers. One's gone a little cloudier than the other, and the bottom layer is the isopropanol layer. So now if we shake this one up a little bit, we'll see if that mixes any better. Doesn't seem to be mixing much better. Right? But the fact that this is a little bit cloudy, you can see there's definitely some mixing going on in there. It's hard to say exactly what, but there's definitely a little, it's not quite as clear and clean as the first one we made, which was water with the cyclohexane. So water and cyclohexane, you get 2 distinct layers even after shaking. The isopropanol and water, we get pretty good mixing even just right out of the gate, just mixing them together when we're adding them into the test tube. And with the isopropanol and cyclohexane, we're getting just a small amount of mixing between the 2 layers. That's why the one layer is a little bit cloudy. So clearly the isopropanol is a little bit soluble inside that cyclohexane layer, but not very much. And that's how you can tell whether or not liquids are able to dissolve in each other. It's all a matter of how well they separate, whether they have more than one layer, if they have slightly cloudy layers and so forth. So you can see a little bit better with that shot the difference between the 3 systems. Alright, so for this experiment we're going to determine how fast it takes a salt to dissolve in hot and cold liquid, so we can understand how temperature affects the ability for something to dissolve or the solubility itself. So the first thing we need to do is we need to weigh 2 0.5 gram samples of salt. So first of all, we're going to turn on our top pan balance and wait for that to initialize. Once that's initialized, we can then open it up. We're going to put on a piece of filter paper that we're going to use as kind of like a weighing book for one of our samples. We're going to zero it, so we're looking at this with exact amounts. So we're going to try and add here about 0.5 grams. So we're going to try and keep this one pretty close. So that way, now so 0.52, what we're going to try and do now is make another sample with the exact same mass. So that says 0.52. We're just going to put that over with the rest of our setup for now. We're going to put another piece of paper, or filter paper on there. We're going to zero that. And we're going to try and make the exact same mass. We're just doing this carefully because we like to get these as close as possible to each other so that when we do this comparison that we're actually comparing 2 very equivalent systems. Alright, and that looks pretty good. Maybe just a little off. If we can just take a piece off, get us close. Alright, so we're within 2/100ths. Alright, so that's the second measurement. So now we know how much we're adding to each. So we have now 2 samples of right around 0.5 grams. So now we can turn the top pan off since we don't need it. Alright, so we have our 2 samples that we just weighed over here. So there's the 2 samples. There was a little bit over 0.5 grams in each, but they were pretty close in weight. We have 2 beakers here, and what we're going to have to do is we need to compare the dissolution of the salt in 2 different temperatures of water. So we're going to put water, equal amounts of water into both. We're just going to put about 50 mils of tap water into each. So we're trying to put the same amount into both. Those 50 mils in there and 50 mils in the other. Notice that I'm using the scale going from bottom to top and trying to get it roughly on that line between the 40 and the 60. And so what we're going to do now is we're going to set up our Bunsen one more time, because we need to make sure that we have hot water. So what we're going to do is hook our Bunsen up, close the vent at the bottom, turn our gas on just like we have been all these other times, and using our splint, light it up. We'll check that our gauze is in about the right spot, which it is, and then we're going to put one of these on there to get hot. Once that water's hot, we're going to take it off for a minute, just let it cool down a couple of degrees. It may be difficult for you to see this, but all we've done is just basically, you can see underneath the gauze there, and all we've done is do the setup where we basically have the hot water boiling on top. And once it's boiling, we're going to bring that back down to our bench level here, and we're going to add the salts. Alright, so as you can see, the water's beginning to boil, so we're going to take that off with the tongs like we normally do. Remember, one-handed operation with the tongs. I'm just going to carefully situate those under the lip. We're going to take that boiling water off, and we're going to put that on our bench. Turn our flame down, and turn that off. So if we come back to our samples now, you can see that we've got 2 samples of the solid there on the filter paper that we already weighed out. We're just letting that water just cool down just a little bit, and then what we're going to do is we're going to time how long it takes for things to dissolve. I'm going to try and put a stopwatch here in the corner for you. And what we're going to do now is we're going to add the salt to each of these as best we can without spilling any. And we're going to try and time this at the same time as best we can. So we're going to put it into the cold. We're going to start the timer. We're going to tilt our first sample in. And we're going to tilt our second sample in. And we're going to bring those so you can see. And we're just going to do our best to stir these or to swirl them to help them dissolve. And we're going to see how long it takes for each of these samples to dissolve. So the hot sample is almost gone. Cold sample is almost dissolved. The hot sample is all gone. So there's your timer right there. And the cold sample is still dissolving. And it looks like it's all gone right there. So you should be able to take those 2 readings of the timer during that time. All right, so we're going to continue looking at the effect of temperature on solubility. Not only are we going to look at how fast or how much time is taken for something to dissolve, we're also going to look at whether or not a system is saturated, whether or not we can dissolve more into the system. So in order to do this, the first thing we're going to do is we are going to weigh out 4 different samples. We're going to keep track of this by noting on our weigh boats what is what. So the first and most efficient way to do this is to weigh the 4 samples. We're going to weigh 1 gram of sodium chloride and 1.4 grams of sodium chloride. We're also going to do the same for ammonium chloride. So first of all, let's turn on our balance and let it cycle through and calibrate for us. Once that is done, we're going to start weighing our first sample, and you'll notice on the actual filter paper weigh boat that we're using, I've noted what it is. So this is 1 gram of sodium chloride. So the first thing we're going to do is make sure, first of all, we get the sodium chloride, which we did. And then we're going to zero our weigh boat, and then we're going to try to get as close as we can to a gram. It has to be roughly 1 gram, not precisely. So this is one of those approximate measurements. but we want to be in the ballpark. We're just a little short, so let's just get that as close as we can. I think we're good enough. That'll be good enough right there. So that's the amount of sodium chloride we're adding. So on the 1 gram filter paper, that's how much sodium chloride we have. You should probably make note of that. And since we have the sodium chloride out, we're going to weigh the 1.4 grams of sodium chloride while we're here. So notice at the top it says 1.4 grams, so we're going to add a bit more than we did last time. I'm going to restart that. I didn't tear. That's why you should get in the habit of just tearing every time. Alright, now it's teared. Now we can add the 1.4 grams. And again, it's an approximate measurement. We want to get in the ballpark though if we can. Alright, that's pretty good. So there's the measurement on the 1.4 grams of sodium chloride. Now what we're going to do is we're going to do the exact same thing, but we're going to do this for ammonium chloride instead. So we're first of all going to weigh out 1 gram of ammonium chloride. So again, we need to make sure we have the right material, which we do. So there's the ammonium chloride. We're going to zero our weighing boat. And then we're going to add about 1 gram. Alright, so on the 1 gram sample, that's the mass that we have, so you can make a note of that. So that's the ammonium chloride, NH4Cl. And then since we have the ammonium chloride out, now we're going to do the 1.4 grams. We're going to zero that weighing boat, and then we're going to add 1.4 grams. Still a little shy, so we're just going to add a bit more. There we go. As you continue to put lids in our containers here to stop any spills, you can make a note of that weight for the last of the 4 initial masses. The 1.4 grams of ammonium chloride has exactly that much in it. All right, now we can get on with the experiment. All right, so now we have our 4 samples weighed out. What we're going to do is we're actually going to start adding these into samples of water, and we're going to look at the relative solubilities of each. So first thing I'm going to do is I'm going to take 2 test tubes, and I'm actually just going to label them A and B so we can tell them apart. So A is going to contain the sodium chloride, and the B will ultimately contain the ammonium chloride. First thing we're going to do is we're going to take the 1 gram sample of the sodium chloride, and we're going to carefully add that to the beaker, the test tube labeled A. And then we're going to take the 1 gram sample of ammonium chloride, and we're going to carefully add that to the beaker that the test tube that we labeled B. And their texture is slightly different. The sodium chloride is a little more coarse than the ammonium chloride, but not by much. So here's an equivalent amount of 2 different salts. Now we're going to add about 5 mils of water to each. So if we add 5 mils of water to this, should be about 5 mils. And then we're going to do the same to B. We're going to add about 5 mils. We want to try and get them about the same, so we can just eyeball that and make sure they're pretty equivalent. And we can add just a touch more to this one, just to make them basically the same. And then what we're going to do is we're going to shake these and just to see, make sure that everything dissolves in. So we'll just use like a little stopper on the end here to take care of that for us. So it shouldn't take too long for all of the salt to dissolve in. As you can see, with a little bit of shaking, it's nearly all completely dissolved in a few seconds. So what you're seeing there is mostly bubbles, not salt. So the salt's fully dissolved in. And then we're going to take the ammonium chloride one, and we're going to do the same thing. We're going to shake that up and see how well it dissolves. So we had 1 gram of sodium chloride dissolved pretty fast. 1 gram of ammonium chloride, it's not quite dissolved yet, but it doesn't look like it's taking much longer in terms of time compared to the sodium chloride. So it'd be fair to say we could dissolve 1 gram of each pretty readily in similar quantities of water. So that's mostly bubbles that you're seeing there. It's not actually undissolved solid. Now, what we want to do is we're going to add now the 1.4 grams. So we can say that the salt is basically dissolved in and the ammonium chloride is basically the same. It's a little more dense, it's looking a little thicker, so maybe solubility might be slightly different for that one, as we'll find out. Now what we're going to do is we're going to add additional salt to tube A. So this is 1.4 grams of sodium chloride that we're adding. And then to tube B, which of course is the ammonium chloride tube, we're going to add 1.4 grams of ammonium chloride. And you can see it kind of stuck to the sides a little bit because it was already wet. We're just going to try and get as much of that into the system as we can. Same on the salt side too. Alright, so we'll just leave those there for a second. Now what we're going to do is we're going to set up a beaker. We want to make a beaker of hot water so that we can dissolve these a little bit better. So we need to, as always, we need to light our Bunsen. We make sure the slit is closed. We get our striker ready, turn the gas on. Sometimes they take a little work. There we go. We can put our beaker on top of the ring stand here. And then we can heat that up fairly quickly and make that water hot. So we're just going to let that go for a few minutes. And when it's hot, we're going to use that to try and dissolve our systems a little better. While that water's boiling, we're going to see if we can get all of the 2.4 grams total mass of sodium chloride that's in this test tube A. We're going to see if we can get it dissolved. We're going to shake it for 3 minutes and see what it looks like. So you can probably take your guesses what will likely happen with the sodium chloride. It's a pretty soluble substance, as I'm sure you've seen used in the kitchens and elsewhere. Not quite dissolved, but it's getting there. So all we're doing here is trying to see if we can get these to dissolve. Still not quite dissolved, so we're going to shake this for a couple more minutes. So we've been shaking the sodium chloride one now for about a minute or so. And if we look at it now, you can see that it's basically fully dissolved. You're seeing a few bubbles in there too from the shaking itself, but the sodium chloride has indeed dissolved. So we can say that after about a minute or so of shaking, the 2.4 grams of sodium chloride is completely dissolved. Now we're going to try with the ammonium chloride one and see if we can get that one to dissolve too. So we're going to shake this and we'll come right back. So after shaking for about a minute to 2 minutes here, we're not really seeing complete dissolution. You can still see at the bottom there, there's a good amount of solid just sitting there. It's not dissolved. And so what we're going to need to do is this, to get this all dissolved, we're probably going to have to do something else. It is worth noting, in actual fact, that the bottom of this test tube is actually very cold. Ammonium chloride salts, when they dissolve, do tend to leave it feeling a lot cooler. So note that after about a minute and a half to 2 minutes of shaking, not all of the 2.4 grams of ammonium chloride actually dissolved. So we're going to leave that there. And we're going to sit and wait for the beaker of water to be done. It's getting close to boiling now. If you look at it here, you can see the bubbles are starting to form. So it's starting to get close to that boiling point. And then what we're going to do is, once it's boiling, we're just going to take it off and we're going to let it cool down like we did before. And we're going to use that as like a hot water bath, basically, to see if that can help our salts dissolve or not. So at room temperature, we already know the sodium chloride is good, but the ammonium chloride apparently didn't fully dissolve. So we should be taking notes of that. It's another observation. So looks like our beaker is close enough to a boil here that we can take it off. What we really want is hot water anyway. It doesn't need to be fully boiling. So we're now going to take that off, put it on our bench, which can tolerate the hot temperature. We're going to turn down our flame, and we'll turn off our Bunsen since we don't need that anymore. It's safe to do that. We're going to just give that water just a minute or two to cool down. Like I said, we don't need boiling water, we just need it to be hot. Now what we're going to do is we're going to put these in the hot water and see if that helps our dissolution at all. Here's the one, the ammonium chloride. This was the one that probably needs the most help. As you can see from that, it's got the solid in it. So we're going to let that sit in there and warm up, and we're going to shake it every so often just to see whether or not we can actually get some more solubility on that. You might be able to see that it's already somewhat improving the solubility. So we're going to leave that in there just a little bit longer. We're going to leave them in there for about 3 or 4 minutes altogether. Just to double check, nothing funny happened to our sodium chloride. You can see clearly on the back, you can see a little bit of sweat there, but there's really no solid in our sodium chloride one, which is violet. There's a test tube A. But if we go back to test tube B, which had a lot of solid in it at the beginning, we can see now as the water is heating up, it's only taken about a minute or so, maybe about minute 30, in order to see that solid basically disappear. What you're seeing on the outside is just a little bit of sweat. There's a tiny bit of solid left at the bottom, but effectively that 2.4 grams of ammonium chloride has now completely dissolved. There's no solid in there at all. So with heating, we actually could dissolve more of the ammonium chloride. We're just going to give this a good shake up. There's still a little bit left on the sides of the test tube here, so we're just going to try and clean that up, just to make sure we did indeed get it all in there. points a little better. So with temperature, what we see is complete dissolution of 2.4 grams of either sodium chloride or ammonium chloride. As you can see here with the close-up, the solids are completely dissolved. Our final test, what we're going to do is we're just going to place them back into cool water, and we'll see if anything happens. So we're going to take A, which is the sodium chloride, and put it back into cool water. Notice this is not iced. I don't want to crack the test tubes. I just want it to be cooler just to see if anything happens as it cools down. So we're going to put that in there, and then B, which is the ammonium chloride we already saw, was completely dissolved as well. So just as a, so remember, this was cloudy before we put it in the hot water. Now we're going to put that in the cool water, and we'll give it about a minute or so to cool down. Just move the hot water out of the way. And we'll see if anything happens in these test tubes as it cools down. And what you'll notice already is in the ammonium chloride, which is test tube B, you'll see there's already a few particles floating around in there. So it looks like some of the solid that was dissolved is beginning to precipitate out. So that's what we call that when the solid comes out of solution. We call it a precipitate. Notice with the sodium chloride, it doesn't look any different than when it was in the hot water. Just a few bubbles from the mixing, but that's it. So as our ammonium chloride is now beginning to cool down a lot more, very clearly a lot more of the solids coming back out of solution. You can see a lot of that ammonium chloride precipitating out of solution. So clearly there's a limitation on how much ammonium chloride we can put in there, and you need to think about that as a part of your data for this experiment. All right, so we're going to look at general solubility now. So we've been looking a lot at solubility relative to temperature, relative to quantities. We're going to see whether or not different materials are soluble and what happens when we mix them together. So I'm just going to label 4 test tubes, A, B, C, and D, so we know which one is which. And then in each of these, we're just going to put a small sample of 4 different compounds. And then we're going to add about 5 mils of water to each one so that we can see whether or not certain materials are soluble. In the first test tube, we're going to add a little bit of barium chloride, and you should always do your check on whether materials are toxic or not. Barium chloride is indeed toxic, so if you use this, you definitely want to be using gloves like I am. So all we're going to do is carefully transfer a small quantity into the bottom of this vessel. The best way to transfer a small quantity of solid using a spatula is to keep the mouths of the vessels close to each other, like this, and then just carefully just drop the material in there. You can tap it down very gently just to get the material to the bottom of the vessel. So now we've added the barium chloride into test tube A. Into test tube B, we're going to use a different spatula because we don't want to cross-contaminate. We're going to add the sodium sulfate. So using the same method, keeping the mouths of the 2 containers close to each other, we're just going to add a small quantity again, not a lot, into that, and we're just going to tap that down. These are all dry, so most material that's on the side should go to the bottom. Then into the third one, we're going to add sodium chloride. So just always make sure you do indeed have the right material. So sodium chloride. We're going to get our third test tube using again the same method for transferring. We're going to get a different spatula so we don't cross-contaminate. We're going to add sodium chloride, and again just a gentle tap just to make sure it goes to the bottom, and that's test tube C. And then finally I have some barium sulfate. I actually just made this earlier, so it's still a little bit damp, but we're going to use this anyway. So going to add that in. It's going to probably run down the side. When we add the water, we'll make sure that goes all the way down to the bottom. But you can see that it's inside the vessel. So what we're going to do now is we're going to add about 5 mils of water to each of these. We're going to try and wash down any material that's on the side of the vessel without touching it. And we're going to do that for all 3. Try and put about the same quantity into each. And of course, with the last one, we're going to try and wash that material down the sides. There we go. Then we're going to look at the relative solubilities of each of these samples by shaking them up just a little bit. So let's take sample A. As you can see, sample A very quickly completely dissolves. There's no solid left in there at all. Okay, sample B has a little bit of solid before I start shaking. And after just a few seconds, you can see that there's really no solid left in it. We'll just give it a shake just a touch more. See if there's any more of this will go in. Alright, so test tube B now is completely clear. The little things you might see are just little bubbles from the shaking and the mixing itself. There's no solid remaining. Sample C. And you should know what each of these is. I'm just referring it to by the letter on the test tube. We just shake that for about 20 seconds. As you can see again, there's no solid remaining in it. The little things that you see in shot here are actually just bubbles from the shaking. Which then only leaves sample D. Sample D, if we mix that up a little bit, we're going to shake that. As you can see, sample D clearly doesn't want to dissolve. So when you're looking at these 4 samples, A, B, C, and D, it's clear that only one of them isn't dissolving, and that is sample D. So you should be making notes of this in your observations. So A, B, and C, there's no solid remaining after a little bit of shaking, and sample D, there's clearly quite a bit of solid remaining. Now what we're going to do is we're actually going to take samples A and B and we're going to mix them together. So we're going to carefully pour one into the other. So I'm going to pour sample A into sample B. So just so you can see, A and B. So I'm going to keep B in shot. And then we're just going to carefully pour A into it. And we should make a note of anything we see. So at the beginning, make an observation as to what A on the left and B on the right, what they look like to you, your observations for that. Then as we mix them together, you should make a statement as to what your observations are when we mix them together. So when you look at that, so it's not B anymore technically. This is now a mixture of A and B together. So write down what you see when we mix those 2 samples together.